Hello everybody. Today we're going to be looking at polynomial operations. We're going to do the notes for our booklet. You should have already made your booklet, and you should have also already put the title and your name on the cover. So we're going to look at what to write on each one of those blank pages. We're going to start with the first, and on this first page we're going to put some vocabulary. Alright, so the first two vocabulary words we're going to look at are term and polynomial. And then we're going to look at an example that helps explain those. So we can see that a term is a number, a variable, or a product. So we could have a number like 3, a variable like x, or a product. So here we would have 4 times x to make 4x squared. A polynomial is a set of terms combined by addition or subtraction. So this whole thing here is a polynomial, and then each one of these are terms, and the subtraction and the addition separate them. The next vocabulary word we're going to look at is going to be like terms. So like terms, for this purposes, we're going to define it as 2 or more terms that have the same variable and the same exponent. This is very important that both of those things are true. So let's look at some examples. So here we can see that the 4 and the 3, those are the coefficients. They don't match, but they don't have to. The important part of the definition is that the variables match. Here we have both of these are x's, and that the exponents match. So both of them have an exponent of 2. This means that they're like terms. But then over here at this one, now we see that the variables match, but the exponents don't. This one has an exponent of 2. This one has an invisible exponent of 1. So not like terms. Then over here, now the exponents match, 2 and 2, but the variables don't. So we have an x and a y, so again, not like terms. Alright, so we're doing operations on polynomials, so we're going to need to get into some operations. The first one we're going to look at is adding. And adding has some objectives we need to work through. So I'm going to read through these for you, and then we're going to look at an example that's going to help break those down. The first objective is to work from a term with the highest exponent to a term with the lowest exponent in order to have an answer in standard form. The second objective, if the term that you're on has a like term in the other polynomial, then you're going to add them together and write the sum into the final answer. If the term that you're on doesn't have a like term, then copy it into the final answer. So those are our objectives. Now we're going to look at an example to help work those out. So in this example, we can see we have 8x squared plus 3x minus 7. That's one polynomial. And then we're adding that to the other polynomial, which is negative 4x cubed minus x squared plus 5. On your paper, when you're doing your work on an assignment, this right here where it says work and this right here where it says answer is the only thing you have to show. But for the notes, we're putting an explanation here on the side in order to explain what's going on over here, because otherwise you're going to look at your notes later and not know what's happening. Okay, so starting off, our first objective says to work from a term with the highest exponent to a term with the lowest. So looking through here, we know we need to start with whichever term has the highest exponent. And as we go through, we can see that negative 4x cubed is that one. It is the highest. We can also see that nothing else has an exponent of 3, which means that there's no like terms for that one. So we're just going to follow the third objective here and drop it into the final answer. So then now that we've done 3, that means that 2 comes next. So looking through here, we can see that our first one we've got is 8x squared. And then across, we can see now we've got negative x squared that's going to match with it. So we have those two like terms, which means we're going to need to show the adding work. All right, so over here is where we've written 8x squared minus x squared, which is equal to 7x squared. So that's our sum. And we're going to take that sum now and follow the second objective and drop that into the answer. All right, next up we have 1. We did 3, 2, and now 1. And in this case, 3x is that. So we see that nothing else has just an x, and that means no like terms for 3x. So that's going to get dropped into the answer here. Finally, after 1 comes 0. So negative 7 is exponent 0, and it has a like term with plus 5. So show that adding work. Negative 7 plus 5 equals negative 2. We take that sum and we drop it into the answer to get our final complete answer. There's nothing else left. We've done them all, and so that's what you'd write. Okay, so adding, now we go to subtracting. Next page. Here, let's pull this down and see what subtracting has. Okay, we've got objectives and then an example here as well. So when we read what it says, we're going to turn subtraction into addition by distributing the negative. And then the second objective says follow steps for adding. So what I've done here is I've copied what was in the adding objectives and just dropped it here as a reminder that these are going to be repeated in subtraction. All right, so now let's look at an example. Okay, so in this example, I've kept I believe the first polynomial the same. Yes, 8x squared plus 3x minus 7. I just kept it the same. But I did change the second polynomial. So we see now we've got subtraction, and then this polynomial is going to be negative 4x cubed plus 8x squared plus 5. All right, so first objective for subtracting is going to be turning it into adding. So we're going to have to show that work. So again, this is what actually goes on your assignment with the work and the answer. And then here is to help you with the notes. So the subtraction turns into addition. And then we are going to change all the signs in the polynomial after the subtraction switched. This is really important. It always goes backwards. We're going to take that and just distribute it backwards, never forwards. So then this changes to positive 4, and this changes to a minus 8, and this changes to a minus 5. All right, so looking through, again, our highest exponent is going to be the 3. And there's still no like terms, so it goes into the answer. 8x squared is next, but now it's a like term with the negative 8x squared, because remember, we're working off of this now. So this one's gone. This is where we're pulling from. So now we have a negative 8x squared. And so the work we're going to show for the sum is here, 8x squared minus 8x squared. If I have 8x squareds and I take all 8 of them away, I have 0. Okay, so then because we have 0, we don't really want to write plus 0x squared into our answer. It's not technically wrong to do that, but it's a bit redundant. So you can see that it's not going to appear in the final answer. All right, after 2 is 1, and we have the 3x for the next term, and it's also not going to have a like term and be dropped into here. Okay, then after that is 0, so -7, exponent 0, like terms, now with a -5. And so the work here, -7 minus 5, the sum is -12. And so that's what goes into the answer for the subtraction. All right. So now we've done addition, we've done subtraction. The next one is multiplication. Division does exist, but we're not going to cover it in this section of notes today. So multiplying comes next. Oh, actually, before I do that, I just saw this important reminder here, and that reminded me that I wrote one at the top of this page too. So let's go back up, and we can see this important reminder that's written here. This one is actually going to encompass adding and subtracting, but it's written here because there's room here. So you might want to add this as well for your reference for later. When adding and subtracting polynomials, you have 3 options for what to do with the terms. You can keep. So, like for example, when we did the -4x cubed here, it didn't have a like term. We kept it the same. Or here, with the +4x cubed, kept it the same. So you can keep. The other option is to cancel. So like here, when we had the 8x squared and we subtracted 8x squared and we ended up with 0, that essentially cancels them out. Or you can combine. So when we had up here with the adding instead, where it was 8x squared and we're subtracting x squared, that's combining. So anytime you have like terms, you'll combine like terms that cancel each other out, or no like terms and you'll keep. So keep, cancel, combine. 3 options for what to do with your terms. All right, back to the multiplying. So let's keep going through here and look through our objectives before we get to the example. Okay. Objective 1, set up a box with columns that match the terms of one polynomial and rows that match the terms of the other. Then you're going to multiply the terms where they meet in the box. Then you're going to find boxes with like terms and indicate those. And then you're going to add all the boxes together in order from highest to lowest so that it's in standard form, and write the final answer. Okay, so let's look at an example, and then hopefully I'll remember the important reminder. Okay, there's a lot here actually. Let's break this down and just do one at a time. All right, first example, and then we'll go to example 2. All right, so example 1, we can see now this looks a little different. Now we have a polynomial here. This particular polynomial has a special name. It's called a binomial. The one we saw before up here, like this one with 3 terms, that would be a trinomial. So 2 terms, binomial. We have a binomial multiplying with another binomial. You can tell that it's multiplying because the 2 parentheses are going to be right next to each other. So then that's how we'll know that it's a multiplying problem. And so now, again, you have this is the work that's actually going to go on your paper. You don't have to write this on an assignment, but this is what we need on our notes. So let's go through each step. I might need to zoom in a bit so that it's a little more clear. All right, so first thing we see here that it doesn't matter which one we do first. So in this one, we've done the second polynomial first. There's two terms for 5x minus 2, so that means we're going to have 2 rows. We could have done it the other way around and had 2 columns. It's your choice. And then we also see that this one, the 4x plus 3, also has 2 terms, so then that means we're going to have 2 columns. So that's how you set up the box, the rows and the columns. And so these are set up on the outside after we do that. So all this stuff on the inside here is not there yet. So actually let me fill those in so you can see what it will look like with just the setup. Okay, so you can see now that this is the box after you've just set it up with the 2 columns, the 2 rows, and then each one of the terms laid out in their particular place. So let's look now at what to fill in for each box. So the first box we're going to look at is these two end up lining up to this spot right here. So that's where we're showing here that we're multiplying 4x times 5x, because you can see in the second objective it's telling us to multiply the terms where they meet. So these 2 terms meet here, and so 4x times 5x equals 20x squared. The next one we're going to look at is where these 2 meet. So 5x and 3. 5x times 3 is how we're going to get that 15x box. That goes there. Next up, 4x times -2 is -8x. Oops, wrong way. There we go. The next one is these 2 line up together and meet right there, and so then -2 times 3 equals -6. Did it again. All right, so now that the box is all filled in, we're going to look at the like terms. So that's what step 3, the objective here, find boxes with like terms, is telling us to do. And we can see here that 15x and -8x are the ones that are like terms, and so then we're going to indicate that with these arrows here. It might seem a little redundant to add that here, but I need you to do that so that you're showing me you know where the like terms are, and also you'll notice in the next example that when the terms get longer, it gets a little more complicated, and you want to make sure you're showing it correctly. All right, so now we're on to the 4th objective, which says to add all the boxes together in order from highest to lowest exponent. So we're going to do that. So the first box here, the 20x squared, that's our highest, so that goes here. The next one, we see that we have our 2 like terms, and we already have written over here that the sum of these 2 is going to equal 7x, because 15x plus -8x, or 15x minus 8x, is equal to 7x. Then that goes in the answer, so these 2 both make that spot there. And then the last one, we have -6, so -6, and then that's our final answer. All right, so let's look at the point reminder. Before we move on, I think it applies and it will make sense if we go ahead and do that. So here we've written in a reminder. This is something that when you're looking at your booklet later, it might be something as like a quick reference. You don't have to read through the whole thing. You can just read this and maybe it'll refresh your memory. So the first one says multiply to make the boxes. That's what we did first. And then add them together. So people every year always get that order mixed up. So having that there might be helpful. Multiply to make the boxes, add them together. Okay? When you're multiplying these terms together, One important thing to remember is that you're going to multiply the numbers and then add the exponents. You can see what we've done here with these. The 4 and the 5 get multiplied together. 4 times 5 equals 20. And then the exponents are going to add. So I have 1 and 1, which is going to make 2. So it's a little different from when we were adding, because when we're adding, we add the numbers and the exponents have to stay the same. So for example, 15x plus negative 8x made 7x. The variable stays the same, so they have to be like terms when you add, but when you multiply, they can be different because you just combine whatever exponents are there. Okay, so something to reference for later. And now let's move on to the last example. All right. And this is actually our last example of the notes. So you have enough room in your booklet, or you can write this on the next page. So example 2, we see that we are now multiplying a binomial times a trinomial. And so our box is going to look a little different, okay? So now we have 2 terms and 3 terms. So I'm going to do the same thing I did before, which is to clear the box and go through it step by step. All right, so again, we can see that the box is cleared. This is the setup that we will start with. 2 terms, so 2 rows. And then 3 terms, so 3 columns. You could also do a 3 by 2. It's up to you. This, I think, just looks neater. It fits easier on lined paper this way too, but your choice. So now we're going to go through one box at a time. We can see that first we're going to start with these 2 here. And this is what I was talking about with the exponents not needing to be the same when you multiply. So here we see that this is 4x and this is 1x squared. And so 4 times the 1 makes the 4. And then x times x squared would make x cubed, because we're basically adding the 1 plus the 2. And so then this is our first box. All right, after that, we can see here that these 2 are going to line up. All right, so we have the 3 times the x squared. So that's going to be the 3 times the 1. And so that gives us 3x squared. I didn't include every single note for each box like I did before, because it's all kind of the same thing after that, because we've already done that here. So if you're a little lost, you can look back up here for what's going on, but I'll explain through each box anyway. So the 4 times the 5 made the 20, and then x times x made the x squared. 3 times 5 makes 15 with an x, and then 4 times negative 2 makes negative 8 with an x, and then negative 2 times 3 makes negative 6. All right, so that's all the boxes filled in. Remember, that was multiplying to make the boxes. Now we're going to do add to put the boxes together into an answer. So we're going to look now for the like terms. So highest exponent that has a like term here is the 2's. This is squared and this is squared, even if my handwriting's not great, but it's okay. So looking at that, we see these 2. We're indicating with our arrow here that we found those like terms. And then we know that it's going to be 23x squared when we add them together. After that, next like terms are 15x and negative 8x. And so we're going to indicate those with each other as well. All right, and so that again, it makes 7x. So now highest to lowest, we see 4x cubed goes into the answer. It doesn't have a match. 20 and 3 made the 23x squared. This is now 7x, and then there's my -6. And that's the final answer. That's all of our polynomial notes. I look forward to seeing you in class. Have a great day. Just kidding, so sorry. Actually, there is one more page. So let's look at that last page. It's a pretty important one. We don't want to miss it. So let's see. It's special multiplying. There are some special circumstances with multiplying that I want you to know about so that you're not surprised when you see them later. So please make sure to also write these down in your booklet. And so now we've got example 1. All right, I'm gonna move through these a little quicker because we've already broke them down so much. Here we can see that x minus 5 is squared. This means that there are actually 2 of these. Just like when we say x squared, that means x times x. X minus 5 squared means x minus 5 times x minus 5. So when you see something like this, you're going to know to set up a 2x2 box. And so you'll see here that that means I've got 2 rows, 2 columns, and they're both x minus 5. X times x makes x squared. X times -5 makes -5x. And again, and then -5 times -5 makes 25. Add them all together, we get x squared, and then like terms, -5 plus -5 makes -10, so -10x, and then 25. Notice that this does not equal x squared minus 5 squared. We don't want to see that this is equal to x squared minus 25 or x squared plus 25. Neither of those are right because you'd be forgetting about this minus 10x here. That's very important. It's a big deal for part of the answer. So then let's look now at example 2. There are 3 of them. I think I was wrong before, so let's just see. Okay. Here we go. So example 2, now things have stepped up a notch. Instead of an exponent of 2, now we have an exponent of 3. So we have x minus 4 times x minus 4 times x minus 4. So that means what we need to do is actually choose 2 of these x minus 4s and do like what we did before, where we do a 2x2 box, and we get an answer from doing that. So x minus 4 times x minus 4 is going to equal x squared minus 8x plus 16. All right, but then that means we've only used 2 of these. It's like this one's gone and this one's gone, but there's still one left. So we got those from that. They made those. And now we need to take that answer that we got before, because these are being multiplied to this. And that means that we now need to multiply these to that third one that we didn't use yet. And so we set that up now. That gives us a 3x2 box. So that x minus 4 that we didn't use multiplied by the product of the other 2. Doing that, we end up now with the like terms here and the like terms here, and our final answer of x cubed minus 12x squared plus 48x minus 24. So let's just double check before we move on. what I wrote here. The first box uses 2 of the x minus 4s, we went over that, and gets an answer. Then the second box takes that answer and multiplies it with the third x minus 4 that wasn't used yet to get the final answer. All right, cool. So now I'm nearly positive that we are ready to be done with this last one. Oh no. Well, let me fix it. All right, we're all put back together now. Last example. Here we go. Example 3. Now we have an exponent of 4. So it's funny, this one has a little bit of a trick to it because you have a few options for how you might want to go about doing this. One of them I think is shorter than the other, so that's the one that I've put here. But you did have the choice if you wanted to. You could follow these steps. You could do a 2 by 2 and use up 2 of them. And then take that 2 by 2 like here and multiply it with a third one to get to here. And then take this answer, which is now 4 terms, and do a 4 by 2 to use that last one. That's one option. I think it's faster to do it a little bit differently though. I prefer instead to do a 2 by 2 box. So then, oops, where did I even erase that? Right at the beginning. Okay, what I like to do is a 2 by 2 box using 2 of them. So here x minus 3 and x minus 3 multiplies together to make x squared minus 6x plus 9. So that means this goes away and this goes away. But you'll notice that after I've used these 2 here, these 2 over here are exactly the same, which means they're gonna give me the same exact answer. And so I can just remember that x squared minus 6x is going to be the product of these, and it's also going to be the product of these. So I'm going to take this product and just multiply it by itself. I'm going to do this answer times this answer. So then I end up with a 3 by 3 box where x squared minus 6x from here is going to get multiplied to x squared minus 6x from here. Then you can see what happens with this one where x squared times x squared makes x to the 4th, and then these are going to multiply, and these, and then here and here, and then these 2. Just like that, you'll see that they create those products as you line them up, add them together. So now, this is the other thing that you want to pay attention to when we get to the like terms, because here we have the explanation that I had gone through, and then now with the like terms, I gave a special note that explains this connection that's happening here. Where before we just had 2 to connect, now actually we have 3, because 9x squared and 36x squared and 9x squared are all like terms. So you actually have to add all 3 of them together. So 9x squared plus 3x squared plus 9x squared equals 54x squared. And so when we write our answer, x to the 4th, then these combine to make negative 12x cubed, and then these 3 combine to make 54x squared. These 2 combine to make negative 108x, and then the 81, and then we have our final answer. And just to prove it, there's absolutely no more notes. We know for sure we're done. And so now I can finish my notes and you can close your booklet, bring it to class and use it for our activities. Have a great day.